Dear viewers, welcome to this second lesson on quadratic. By the end of this lesson, you should be able to identify a quadratic equation, solve a quadratic equation by factorization, formulate and solve problems on quadratic equations. But before we start our lesson, let us recall what we did in our first video. We identify a quadratic expression as ax squared plus bx plus c, where a, b, and c are real numbers and a cannot be zero. For example, 3x squared plus 5x plus 2 is a quadratic expression. We factorize quadratic expressions. For example, we factorize 6x squared plus 3x to obtain 3x into 2x plus 1. We factorize x squared minus 3x minus 3 squared to obtain x minus 3 into x plus 3. We factorize x squared minus 3x minus 10 to obtain x minus 5 into x plus 2. We factorize 2x squared plus 6x plus 4 to obtain 2 into x plus 1 into x plus 2. Now, what is a quadratic equation? It is an equation of the form ax squared plus bx plus c is equal to 0, where a, b, and c are real numbers and a cannot be 0. Now, what is the difference between an expression and an equation? A quadratic expression is of the form ax squared plus bx plus c, where a cannot be 0, whereas a quadratic equation is of the form ax squared plus bx plus c equals to 0, where a cannot be 0. So in an expression, there is no equal to sign, whereas in an equation, there is an equal to sign. So let us now see whether the following are quadratic equations. First, x squared is equal to 0. X squared can be rewritten as 1x squared plus 0x plus 0 is equal to 0. So here, a is equal to 1, that is not 0, therefore x squared is equal to 0 is a quadratic equation. Second, 3x plus 5 is equal to 0 can be rewritten as 0x squared plus 3x plus 5 is equal to 0. Note here that a is equal to 0, therefore 3x plus 5 is equal to 0 is not a quadratic equation. Third, 5 minus 4x plus 7x squared is equal to 0. Note here that this is not in the form ax squared plus bx plus c is equal to 0. So we can rewrite the equation starting with 7x squared minus 4x plus 5 equals to 0. Here, a is equal to 7. Therefore, 5 minus 4x plus 7x squared is equal to 0 is a quadratic equation. Part 4, 3x is equal to negative 2x squared plus 4. Again, this is not in the form ax squared plus bx plus c is equal to 0. So we rewrite the whole equation, sending all terms on one side. Starting with negative 2x squared, we have 2x squared plus 3x minus 4 is equal to 0. So here a is equal to 2. Therefore, 3x is equal to negative 2x squared plus 4 is a quadratic equation. Solutions of quadratic equation. To solve a quadratic equation, example, x squared minus 5x minus 6 is equal to 0, means you find the value or values of the unknown x. Consider n times n is equal to 0. We know that 0 times n is 0, or n times 0 is 0. Thus, if m times n is equal to 0, then either m is equal to 0 or n is equal to 0. This is known as the null factor law. The null factor law can be used to solve quadratic equations. For instance, if we have x into x minus 1 is equal to 0, using the null factor law, we have either x is equal to 0 or x minus 1 is equal to 0. That is, x is equal to 0 or x is equal to 1. Example 1. Solve the equation part A, x into x minus 5 is equal to 0. Part B, x minus 4 into x plus 7 is equal to 0. So using the null factor law for part A, we have either x is equal to 0 or x minus 5 is equal to 0. Thus, x is equal to 0 or x is equal to 5. Note here we can verify the answer by substituting x is equal to 0 in the initial equation. For example, putting x0 here, we have 0 times negative 5, which is 0. Or if we substitute x by 5 in the equation here, we have 5, then 5 minus 5, 0. So 5 times 0 is 0. Part B, x minus 4 into x plus 7 is equal to 0. Using null factor law, we have either x minus 4 is equal to 0 or x plus 7 is equal to 0. So we have x is equal to 4 or x is equal to negative 7. Again, we can substitute x in the initial equation to verify whether the solution is correct. Example 2, solve the following equation. Part A, x squared minus 9 is equal to 0. So in this case, we need to factorize x squared minus 9. So we write x squared minus 9 is equal to x squared minus 3 squared, which can be factorized to obtain x minus 3 into x plus 3. Therefore, x squared minus 9 can be written as x minus 3 into x plus 3 equals to 0. Using the null factor law, we have either x minus 3 is equal to 0 or x plus 3 is equal to 0. Therefore, x is equal to 3 or x is equal to negative 3. We can also solve this problem by making x squared subject formula. So we can send negative 9 on the right. So we have x squared is equal to 9. Taking square root on both sides, we have x is equal to plus or minus square root of 9. So x is equal to plus or minus 3. X is equal to 3 or x is equal to negative 3. Again, we can substitute into the equation, the initial equation, to verify whether the answer is correct. Part B, x squared plus 4x minus 21 is equal to 0. So we need to factorize x squared plus 4x minus 21. The product here is negative 21. The sum is 4. So we need two factors of negative 21 such that their sum is 4. We know that negative 3 times 7 is equal to negative 21, and negative 3 plus 7 is equal to 4. So the two factors we are looking for are negative 3 and 7. So to factorize x squared plus 4x minus 21, we have x minus 3 into x plus 7. So to solve x squared plus 4x minus 21 is equal to 0, we have x minus 3 into x plus 7 is equal to 0. Either x minus 3 is equal to 0 or x plus 7 is equal to 0. Therefore, x is equal to 3 or x is equal to negative 7. Again, we can substitute the values of x into the initial equation to verify whether the answer is correct. Example 3, part A, x squared is equal to 7x plus 18. Now, this is not in the form ax squared plus bx plus c is equal to 0. So we collect all terms on one side. We have x squared minus 7x minus 18 is equal to 0. So we factorize x squared minus 7x minus 18 to obtain product is negative 18 here. The sum is negative 7 here. So we need two factors of negative 18 such that their sum is negative 7. So we know that 2 times negative 9 is equal to negative 18, but 2 plus negative 9 is equal to negative 7. So the two factors we're looking for are 2 and negative 9. Therefore, to factorize x squared minus 7 minus 18, we have x plus 2 into x minus 2. Therefore, to factorize x squared minus 7x minus 18, we have x plus 2 into x minus 9. Using the null factor law, we have either x plus 2 is equal to 0 or x minus 9 is equal to 0. Therefore, x is equal to negative 2 or x is equal to 9. Part B, x minus 2 is equal to 15 over x. Now, this is not in the form ax squared plus bx plus c is equal to 0. So we cross multiply to obtain x into x minus 2 is equal to 15. We expand the left-hand side to obtain x squared minus 2x is equal to 15. We collect all terms on one side. So we have x squared minus 2x minus 15 is equal to 0. We factorize left-hand side to obtain x plus 3 into x minus 5 is equal to 0. So x is equal to minus 3 or x is equal to 5. Solving problem involving quadratic equation. So example 4, the sum of a positive number and its square is 72. Find the number. So if we let the positive number be x, so the question says the sum of a positive number and its square is 72. So if we let x be the number, positive number, then its square is x squared. But we know that the sum of the positive number and its square is 72. So it means x plus x squared must be equal to 72. So we have formulated a quadratic equation. So x plus x squared is equal to 72. So we can rewrite the equation with all terms on the left. X squared plus x minus 72 is equal to 0. So we need to factorize the left-hand side. So we have x minus 8 into x plus 9 is equal to 0, which we solve to obtain x is equal to 8 or x is equal to negative 9. But the sum of a positive number. So in this case, x is positive. Find the number. So if x is positive, therefore x must be 8. We reject x is equal to negative 9. So in this case, the answer is 8, as the number is positive. So we can verify whether the answer is correct. For example, here, if x is 8, then x squared is 64. So 8 plus 64 is equal to 72. So the answer is correct. Example 5, the width of a rectangle is 5 centimeters shorter than its length. Given that the area is 36, find the length and the width of the rectangle. So if we let x be the length of the rectangle, this is a rectangle, the length is x. Now the width is 5 centimeters shorter than the length. So the width must be x minus 5. Now, we also know that the area of the rectangle is 36. So area is 36. But we also know that area of a rectangle is equal to length times width. So area of rectangle is 36, the length is x, and the width is x minus 5. So we can simplify the right-hand side to obtain 36 is equal to x squared minus 5x. We can rewrite this equation with x squared minus 5x on the left and collect all terms on the left. So we have x squared minus 5x minus 36 is equal to 0. So we factorize the left-hand side to obtain x minus 9 into x plus 4 equals to 0. So we solve, we obtain x is equal to 9 or x is equal to negative 4. Now, length cannot be negative, so the length is 9. So therefore, x is equal to 9. So we reject x is equal to negative 4 as length cannot be negative 4. So the width is x minus 5, but we know x is equal to 9. Therefore, the width is equal to 9 minus 5, which is 4. Therefore, the solution to this equation are length is equal to 9 centimeters and width is equal to 4 centimeters. We can verify the answer. So if the length is 9, the width is 4, therefore the area would be 9 multiplied by 4, which is 36. Therefore, these answers are correct. Now, let us sum up what we have done in this lesson. We first identify a quadratic equation as ax squared plus bx plus c is equal to 0, where a, b, and c are real numbers and a cannot be 0. We solve quadratic equation by factorization, and then we formulate and solve problems involving quadratic equations. So dear viewers, with this, we reach the end of our lesson. I hope that you enjoyed the lesson and hope that you will work out questions on quadratics. Keep watching our video. Till then, all the best. Take care. Bye.